Hello everyone, welcome to this class on finite element analysis, and in this class let's learn this problem on heat transfer. In heat transfer you have two types of problems. One is problem on composite wall, another one is problem on fins. And problem on composite wall is one of the important type of problem that is asked in the exams very frequently. And here let's learn this problem. Determine the temp and generally in heat transfer, let it be composite wall or let it be fins, you try to study this temperature distribution. At the nodes you try to determine the temperatures. So these are the nodes. There are four nodes, therefore there will be four temperatures. Determine the temperature distribution in the composite wall using 1D. 1D means one dimensional heat elements. Use elimination method approach. So they have directly given in the question to use elimination method, so you will have to use elimination method of handling boundary conditions. The given data is K1. K is nothing but thermal conductivity. Don't get confused with elemental stiffness matrix. Generally in other chapters K is stiffness matrix, but here in heat transfer K means thermal conductivity. Even you have the another K that is a stiffness matrix as well, but this is small k. Capital K will be stiffness matrix while small k will be thermal conductivity. K1, that is for you have element 1, element 2, element 3, therefore K1 is 20 watts per meter degree Celsius, K2 is 30 watts per meter degree Celsius, K3 is 55 watts per meter degree Celsius. H is nothing but convective heat transfer coefficient, and that is given as 30 watts per meter degree Celsius. And T infinity is called as surrounding temperature or ambient temperature, or any, or you just tell like that. So T infinity equal to 900 degrees Celsius, and A equal to unit area. So in composite wall problems, even though if it is not given, we will have to assume A as unit area. Unit area in the sense it is 1 meter square. We assume to be 1 meter square. So now let's try to write the given data first. So given data. So this is the figure that is given. So let me try to explain you that. So let me try to write the given data. Given data is very, very important. So let's try to write this K1, K2, K3. K1 is 20 watts per meter degree Celsius, and K2 is 30 watts per meter degree Celsius, while K3 is 55 watts per meter degree Celsius. Apart from that you have H, that is 30 watts per meter degree Celsius. You can see all these are in watts per meter degree Celsius. So you can just see all these parameters are in meters. So I don't think any other conversions are required. You can just retain with the same. Apart from those, just see what are the other data that is given. T infinity is given as 900 degrees Celsius. So that is also given in degrees Celsius. All these things are also in degrees Celsius. Even there also conversion is not required. Apart from that, you have area. Area that is given. Area is taken to be unit area, that is 1 meter square. That is also in meters. Already all these are also in meters. So therefore no conversion is required. So let me try to write here this the length of element 1, element 2, and element 3. Element 1 length is 0.4 meters, element 2 length is 0.2 meters, element 3 length is 0.2 meters. So you have, so everything, all these parameters are either in meters or degrees Celsius or just like that. Apart from that, there is no any other thing that is given. Here you can just see this T4, that is nothing but TO. TO means outer temperature, that is this outer wall temperature is, or outer surface temperature is 25 degrees Celsius. T0 or T4 equal to 25 degrees Celsius. That is also in degrees Celsius. All these things are also in degrees Celsius. Suppose sometimes if any other thing is given in Kelvin, you will have to convert it to degrees Celsius, all that. Okay, now let me try to go with the problem. The solution. The first step will be FEA model. So let me try to write the FEA model. So here there are three elements. So therefore this is, so first one is little bigger. So let me try to write little bigger. The second and third are equivalent at 0.2 meters. So this is node 1, this is node 2, this is node 3, and this is node 4. So this is length of element 1, which is 0.4 meters. This is length of element 2, which is 0.2 meters. This is length of element 3, which is 0.2 meters. So this is element 1, this is element 2, this is element 3. And at element 1 you find T1, at element at node 2 you find T2, at node 3 T3, at node 4 T4. So this all ends the FEA model. So this is the first step. So this is the first FEA model, is the first step every time. So this is the FEA model. The second step is elemental stiffness matrix. For conduction, for convection and conduction you do it. So for conduction or conduction matrix, you can just write it simply as conduction matrix. Conduction matrix is generally given by Ke equal to K into Ae divided by Le, where 1 minus 1 minus 1 and 1. So this K is nothing but the conduction, the thermal conductivity of this element 1, element 2 and element 3, while this K is nothing but the stiffness matrix. So like that I'll just try to write it. K1 equal to K into the small, small k1 equal to capital K1 into A1 into divided by L1, 1 minus 1 minus 1 and 1. Here, as I told you, this capital K1 is thermal conductivity, which is given in the given problem, while this small k1 is the stiffness matrix. So in heat transfer, don't get confused with this. This is very, very important. This one is nothing but this 20 into area. Area is given to be 1. Therefore, area A1, area A2, area A3, completely is going to be constant. 20 into 1 divided by L, length L1, 0.4. 1 minus 1 minus 1 and 1. So upon simplification of this one, you will get 50. So 50 into, if you try to multiply 50 inside, I'm going to get like this. So this is going to be K1. Similarly, if I try to do for K2 and K3, I'm going to get it like this. So let me try to do that. K2 equal to like 30 into 1 divided by 0.2. That is, this is thermal conductivity of element 2. This is area A1. This is length L2. So 1 minus 1 minus 1 and 1. So upon solving this, you will get 150. So let me try to write that. So similarly, K3 thermal conductivity is 55, while area is 1 and length is 0.2 again. So upon solving this, I'm going to get it as 275. 275 minus 275 minus 275 and 275. So already we had nodes 1, 2. Here this is nodes 2, 3 and this is nodes 3, 4. And whichever we got in the previous problem, this one was, it's 1, 2, 1, 2 and this is 1, 2. So now we'll have to, after this, next step will be stiffness matrix due to convection. After this only you'll be writing the global stiffness matrix. Now you have to write the stiffness matrix due to convection. So this is very, very important, because here is what you will be making the mistake. Stiffness matrix due to convection, you totally have two formulae. I have the formula list over here. If you can observe it clearly, you can just see here on the left hand side, on the right hand side. So h dash end equal to AH, 1 will be here, 1 0 0 0, and now if it's on the right hand side, 1 will be here at the end. But how do you find whether it's on the left hand side or on the right hand side? You can just see in the given figure clearly. Just observe in the given figure, if something is given like this, h into T infinity, if it is given on the left hand side, then you will have to use this left hand side formula. You have to use this left hand side formula. Suppose if it is given on the right hand side, then you will have to use this right hand side formula. So you will have to use accordingly. And sometimes it will be given in the question itself, that is the convective heat transfer coefficient is occurring on the left hand side, on the right hand side, or sometimes they might also give inner surface, outer surface also. Inner surface means it's on the left hand side, outer surface means it is on the right hand side. So always remember that. So here in this problem it is given on the left hand side, therefore the formula is going to be, this is the formula, that is on the left hand side, h dash end equal to AH1000. So let me try to write that formula. So h dash end equal to A into H 1000. So what is A? A is the value of, that is area, and H is given to be how much? H is given to be 30. If you just go back to the question, you will understand in the given data. So this one, if you try to 1 into 30 will be 30, and if you're trying to multiply it inside, you're going to get this as 30, 0, 0 and 0. So this is nothing but going to be h dash end. Okay. Now you see, this is only for there are only 2 cross 2 matrix. Therefore, it is going to be only for 1, 1, 2 and 1, 2 only. But there are totally 4 nodes. So what you have to do is you will have to expand that to 4 nodes. You have to expand that to 4 nodes. Like, okay, let me just tell you that later while writing the global stiffness matrix. The next step is going to be force vector or load vector. So force vector or load vector. Even force vector or load vector also have the formula here. So if you just look at here, force vector due to free end convection on node 1, or you can just see on any node. And this is on the left hand side. This first formula is on the left hand side. The second formula is on the right hand side. For left hand side it will be 1 0. For right hand side it will be 0 1. As you know, in this problem it is given on the left hand side. Therefore it is going to be 1 0. So let me try to write that formula. That is f dash h equal to AH t infinity, it's going to be 1 0. So it's going to be 1 into area is 1. I mean, now this convective heat transfer coefficient is 30. This is 900 and 1 0. So upon multiplying this inside, you will get 27,000 0. That is 30 into 900 is 27,000. So this is also for nodes 1 and node 2 only. But we will have to do it for 4 nodes. Okay, now let me try to write the global conduction matrix. Global conduction matrix. Global conduction matrix is nothing but capital K, which is K1 plus K2 plus K3. So which we have done, so which you know it already, I believe. So I'll just try to write it directly, because by this time all of you must be knowing it. So 50 minus 50 0 and 0, minus 50 200, minus 150 0, 0 minus 150 425 minus 275. Suppose if you have doubts in writing the global stiffness matrix or global conduction matrix, refer my previous videos on analysis of bars. All that you will understand it much better. There are totally 4 nodes, therefore it's going to be 1 2 3 and 4, and similarly 1 2 3 and 4. Now, as I was telling you, we have to write this global convection matrix as well. So global convection matrix. Later on you will have to add both. So global convection matrix. So global convection matrix. So how are you going to write the global convection matrix? Already we have written this convection matrix for 2 nodes, but when you have to expand it to 4 nodes, here there are no any other elements present. So therefore directly you can try to write it 0. For 1 2 1 2 we have got how much, what do we have got that? So we have got 30 0 0 and 0. But we'll have to expand that to 4 nodes, 1 2 3 and 4. Similarly 1 2 3 and 4. So we'll have to expand that to 4 nodes. So all other we are going to replace it with 0, because it is not given in the, so it's given only this 30 is what we have found out, that at the left hand side. Therefore only here it's going to be 30, all other it's going to be, so this is going to be H. So now what we have to do, we'll have to add both. Add this conduction matrix as well as add this convection matrix. This is also a 4 cross 4 matrix. Even this is also a 4 cross 4 matrix. Adding both conduction and convection matrix, we are going to get the answer. So here you can see all other terms, all other elements here are 0. So therefore if you are adding 0 here, it will be the same except this first element. So 50 plus 30 is going to be 80. Apart from that, all other elements are going to be the same only. So now let me try to write that next one. So before writing that, let me try to write the equilibrium equation directly. In that there I can write it. So equilibrium equation is K into T plus H into T will be equal to F. Okay, here I have to write this F as well, but F also let me try to write it directly. Here if I try to take T common, I'm going to get it like K plus H, open a big bracket, it's going to be T, which is equal to F. So K plus H, as I told you earlier, in these two matrices you have to add both these matrices. So 50 plus 30 is going to be 80. Apart from that, minus 50 plus 0, 0 plus 0, all that is going to be the same, this matrix itself, except this first element. 50 plus 30 is going to be 80. Because if you're adding 0 here, again the answer is going to remain the same. So let me try to write that. So this K plus H, if I'm trying to write, I'm going to get it as 80 minus 50, 0, 0, minus 50, 200, minus 150, 0, 0, minus 150, 425, minus 275, 0, 0, minus 275, and 275. So this is going to be K. Next, T is going to be T1, T2, T3 and T4. That is going to be equal to F. F we have already found out. That is the load vector. That is force vector or load vector. That is for 2 nodes we have got 27,000 and 0 for 2 nodes. So what will the value of force be for nodes 3 and 4? It's just going to be 0, because that's what we have got only for 2 nodes. So for the remaining 2 nodes, you're just going to write it as 0. So this is going to be for, so now we'll have to solve this. So it is not like direct elimination method, it's not just like that. So you'll have to So we have to, it's not like directly you're going to apply the elimination method and solve. So before that we'll have to do one more change here, just like not like just like directly in like bars and beams. Okay, now we'll have to multiply any one of the row here with this matrix. So before even applying the bound, before even what to say multiplying directly, we'll have to do that. Already T4 is given in the problem, that is 25 degrees Celsius. We have to only find out T1, T2, T3 using elimination method. So first thing what you will have to do is multiply any one of these row with this column. So you will have to decide which row you are going to multiply. Suppose if I'm trying to multiply this first row with this column, so what do I get? Just imagine 80 into T1, I'm going to get 80 T1 minus 50 T2. 0 into T3 and 0 into T4 is going to be 0. I can't apply the what to say now, well, the T4 value is given. T4 is given already 25 degrees Celsius. So something, if I'm getting some number, with that number if I'm trying to multiply 25, I'll get, I can easily identify this T1, T2, T3. So I have to identify a row such that where you can multiply a number here. In this fourth column I should have, I should have some numbers to multiply with this T4, because T4 is given. So I have to choose such a row that here in this fourth column I should not have any zeros. That is, whichever temperature is given in that particular, now this fourth nodal temperature is given. Therefore in this fourth column I should have some numbers. That is very, very important. So even if I look here, first and second row, it is completely 0. So therefore I can't choose this first and second row, because 0 into T4 is given. It will directly be 0. Therefore I can't apply this 25 number. So I can't choose this first and second rows, because even here also 0 into T4 it's going to be 0. I can't choose that. Suppose if I'm choosing this third and fourth row, let's see. If I'm trying to choose this fourth row, yes, third and fourth row is applicable, because minus 275 into T4, 275 into T4, I can choose any one of them. But yet I can't choose both. I can choose any one of them only. Which one shall I choose, third or fourth? If I'm trying to choose fourth, let's see. Here there are many zeros compared to this. So always choose a row which has very, very less zeros. So if you just see here, either it has 2 zeros, even it has 2 zeros, you can directly eliminate them also. Among this, if I'm trying to choose this or this, means this is, if I'm choosing the second row, 0 into T4 is going to be 0. I can't apply this number. So therefore eliminate this. Just try to take this row. If I'm trying to take this row, 0 into T1, let me try to multiply and show you so that you will understand it better. 0 into T1 minus 150 into T2 minus 150 into T2 plus 425 into T3 plus 425 into T3 minus 275 into T4 minus 275 into T4. Therefore I'm able to multiply this minus 275 with this T4, because if 0 was there, 0 into T4 would have been 0. Therefore I wouldn't have got the answer properly. I should have got some number. I should have got a number here to make it multiply, because if it's 0 into 25 means it will be directly 0. I can't do it. I'll not get the answer better. I need some number more apart from 0 that is equal to this third element. Third element is 0. Now 0 into T1 is going to be 0. I'm directly going to get minus 150 T2 plus 425 T3. This minus 275 T4, I'm going to send it to the right hand side. 275 into, so T4 is 25. This I'm going to write it as minus 150 T2 plus 425 T3. So 275 into 25 is found to be 5500. So if you just apply in the calc, you will get the answer. So now, so let me just try to write this 0 T1 only. Now this value of 5500, we got it by multiplying this third row with this column. Understand, that is very, very important. Why did you choose this third row? Because here, as I told you, any row if you take it, it should have least number of zeros. Suppose if these two columns are having only 2 zeros, okay, you can directly eliminate them. If I'm choosing this or this, if I'm taking this, 0 into T4 would have gone 0, because T4 is given value. 0 into T4 would go 0. That's why I didn't choose this. But this one, if I'm choosing, I'll get minus 275 into T4. So that's the reason why I'll choose this. So understand, that is very, very important. That is equal to 0, and I've finally got the answer 5500. Now this 5500, I'm going to replace it here in this value of 0. Instead of 0 replacing, I'm going to add that with this 0. 0 plus 5500. That is very, very important. So let me try to write this again. Okay, so I've just written this over here again. So after adding that 5500 to this third element over here. Okay, now what do we have to do is, we'll have to apply the elimination method. Apply the elimination method. So after doing that first, that previous step, only then you will have to apply the elimination method. So apply the elimination method. So now when applying the elimination method, in this problem, this T4 is given. That means fourth node fourth node temperature is given, therefore you will have to eliminate fourth row and fourth column. So understand that is very very important. So if you try to write the remaining one, so this also completely gets eliminated. So only the remaining elements are there. Let me try to multiply that now. 80T1 minus 50T2 plus 0T3 equal to 27,000 minus 50T1 plus 200T2 minus 150T3, it is equal to 0. 0T1 minus 150T2 plus 425T3 equal to 5500. So now if you put it in the calc, if you take equation, number of unknowns are 3, you can enter the value of A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. So if you are entering all these values, the final values are you're going to get T1 as 439.04 degrees Celsius, T2 is 162.47 degrees Celsius, T3 is 70.285 degrees Celsius, and T4 is already given 25 degrees Celsius. So this number is already given. You can identify whether the correct whatever you have written is correct or not by one method. The temperature should be reducing from this first nodal to the fourth node. That is very very important, because heat always flows from a region of higher temperature to a region of lower temperature. So higher temperature 439, the next one is 162, next one is 70, next one is 25. So by this itself you can identify that the problem whatever you have done is correct. So this is what you're going to identify in this problem, the nodal temperatures T1, T2, T3 and T4. I hope you have understood this. Thank you.